Hey everyone, and welcome. Today we are going to tackle a service that has totally changed how we think about data analysis, Amazon Redshift. Seriously, if you've ever wondered how huge companies dig through mountains of data, we're talking petabytes, to find those little nuggets of gold, well, this is how. So let's jump right in.
So here's our game plan. We'll start with a really common problem, the analytics bottleneck. Then we'll bring in Redshift as the hero of the story, break down its superpowers, talk about the real-world benefits, and finish up with its newest form, Redshift Serverless.
All right, let's kick things off with the analytics bottleneck. See, before you can appreciate the solution, you gotta understand the problem. And trust me, it's a problem that businesses run into all of the time.
Does this sound familiar? Why are my big reports so slow? You have all this amazing data, you need to run a huge query to make a critical business decision, and it just crawls. It feels like it takes forever, right? Now, this isn't a glitch. It's because you're probably using the wrong tool for the job. It's kind of like trying to tow a boat with a Ferrari. It's just not what it was built for.
And at the very heart of this problem is the difference between two kinds of databases. The ones most of us use every day are for online transaction processing, or OLTP. Think about an e-commerce site. They are amazing at handling tons of small individual sales. But when you want to do that big picture analysis, what we call online analytical processing, or OLAP, that's when they just fall over.
Okay, let's dig into that. A traditional OLTP database uses what's called row-based storage. The best way to think about it is like a filing cabinet. For every single customer order, you have a folder, and inside that folder is everything about that order. The ID, the customer name, the price, the quantity, it's all bundled together in one neat row. Perfect if you need to pull up one specific order, right? Super fast. But here's the catch. What happens when your boss asks, what was the total quantity of every item we sold last quarter? Well, to answer that, the database has to open every single folder in the filing cabinet. It has to look past the customer name, past the price, past the discount, just to find that one little piece of data, the quantity. Now imagine doing that millions of times. You can see why your reports grind to a screeching halt.
And that is precisely where our topic for today comes into play. To fix this, you don't need a faster version of the same old database. You need a totally different approach, one that's designed from the ground up specifically for analysis.
And that brings us to Amazon Redshift. At its core, it's a data warehouse that lives in the cloud. It's built to handle absolutely insane amounts of data. We're talking petabytes, which is millions of gigabytes. But the real magic is that it lets you ask incredibly complicated questions of that data using the same standard SQL you already know, and it gets you answers at speeds that just seem impossible.
So what's the secret sauce? How does Redshift actually pull this off? Well, it's not really magic, but it might as well be. It all comes down to two foundational ideas that give it these incredible superpowers.
The first superpower is columnar storage. Remember our filing cabinet? Redshift throws that idea out the window. Instead of storing data in rows, it stores it in columns. So all the order prices are stored together in one block, all the quantities are in another, all the customer names in another. Now, when you ask for the total sales quantity, it just reads that one single block of data, the quantity column, and completely ignores everything else. It's a simple switch, but the performance gain is absolutely massive.
In fact, there's a cool little theory that this is how the service got its name. You're literally shifting the data's organization, a redshift from rows to columns. It's a pretty neat way to remember how it works.
Redshift's second superpower is called Massively Parallel Processing, or MPP. This is the idea that many hands make light work. Instead of using just one powerful computer to answer your query, Redshift uses a whole team, a cluster of them. It takes your huge, complex question, breaks it into a bunch of smaller jobs, and has all these computers, or nodes, work on their little piece at the same time. It's the ultimate divide-and-conquer strategy for data. So here's a quick look at how that actually happens. Your query first goes to a single leader node. You can think of the leader as the project manager or the brain of the operation. It figures out the best way to get the job done, then it splits up the work and hands it out to a bunch of compute nodes. These compute nodes are the workforce. They do all the heavy lifting in parallel. Once they're done, they send the results back to the leader, who puts it all together for the final answer. It's a really elegant system.
Okay, so we know how it works, but let's get down to brass tacks. What's the actual payoff? Why do so many companies choose Redshift?
It really boils down to a few major things. First, you get absolutely blazing performance on those complex analytical queries. Second, it's often way more cost-effective than traditional on-premise data warehouses. Third, scalability. You can literally resize your warehouse, adding more power or scaling it down in minutes. Plus, it's got rock-solid security, and it plugs in perfectly with the rest of the AWS ecosystem, like storing data in S3 or building dashboards in QuickSight.
And we're not talking about some niche product here. More than 15,000 customers are using Redshift. We're talking huge names like Pfizer and McDonald's. When you see that kind of widespread adoption, you know it's solving a real important problem.
And of course, when you have that much important data, security has to be priority number one. Redshift has you covered. Your data is encrypted whether it's just sitting there on a disk or flying across the network. You can isolate your entire warehouse in its own private slice of the cloud, and you get super granular control over who can access what.
But the story doesn't stop there. Just like everything else in the cloud, Redshift is always evolving, always getting easier and more powerful.
And that brings us to Redshift Serverless. The idea here is beautifully simple. What if you could get all that incredible power from columnar storage and MPP, but without ever having to think about managing servers or clusters? That's serverless. You just show up with your data and your questions, and AWS handles the rest.
So what's the real difference? Well, with the classic provisioned model, you pick a cluster size and you pay for it to be on 24/7, whether you're using it or not. With serverless, you don't manage anything. AWS automatically spins up the resources when you run a query and spins them down when you're done. And the best part? You only pay for the exact amount of compute you use, right down to the second. For a lot of people, that's a huge game changer for both cost and simplicity.
So at the end of the day, it all comes down to this question. In a world that runs on data, are the tools you're using built for yesterday's problems or for tomorrow's? Trying to do modern analytics with old database tech is like trying to drive with the parking brake on. Tools like Redshift aren't just about getting faster reports. They're about building a foundation that lets you ask the questions you haven't even thought of yet. It's about, well, finally taking that parking brake off. Thanks so much for tuning in.